My name is Erin Gallagher. I'm the head of education here at MathSpace. I've had the wonderful pleasure of being here with MathSpace for 10 years, just celebrated that anniversary recently. So before that, I was a teacher predominantly in the ACT across many years, different types of environments. So yeah, my passion is curriculum. So I've been able to do that for a long time. And beside me is Mo, our founder.
Hey everyone, I noticed a lot of names that I recognize and also a whole bunch that I don't. So if I have met you before, it's great to see you again. And for those that haven't, I'm Mo, I'm one of the founders at MathSpace. And today on our webinar, we will be showing off our new textbooks for the Victorian curriculum.
Yeah.
So funny how times change. So it's interesting. We're kind of really thinking this is back to the future. You'll see today some of our, really going to print textbooks, and you'll also see some of the really digital enhancements that we're looking at, and we just see a place for both. And just a little bit of like why now for MathSpace, and kind of the aha moment for us. Probably two things. One, COVID times. Usage went really up with MathSpace. A lot of schools using us really well through that period. Obviously, it was a lifesaver for a lot of schools. A lot of schools in Victoria, in particular, doing us. If it wasn't for MathSpace, I don't know what we would have done. And then what we saw post-COVID, we saw schools that had used us really, really well. The usage dropped back to even like lower than pre-COVID levels. And so we asked, hey, what's going on? Is everything okay? And like, yeah, we still love MathSpace, still use it all the time. We're actually printing some of the worksheets and getting students to do it on pen and paper. And it was kind of a moment of like, okay, there needs to be a place for both, and it depends on different schools. So some schools will be fully ready for digital, and other schools will just want to detox the students at that point. And then the other part was really we've started to introduce worksheets in MathSpace. A lot of you that have used MathSpace will be familiar with. And that was meant to be the offline component where we could include a lot more questions that were open-ended, reasoning, problem-solving questions, where we didn't have to scaffold the questions so much. And as we did that, we found that more and more of those kinds of questions are best done in an offline environment, and so it led us to kind of go, let's build them into textbooks as well. So
yeah. You'll see a lot of that when we showcase some of the content a bit later. The open-ended richness that you can get from being able to articulate your answers to understanding and reasoning type questions are really powerful. So
yeah, and so one of the beautiful things is with the curriculum, and having a big focus on that, we've built this from scratch for the new curriculum. So we haven't had previous textbooks that we've adapted to this new curriculum. We've kind of went like, what is the intention of this curriculum? Let's build it from scratch for this new curriculum. And hopefully you'll see those elements throughout the webinar today.
Shine through, I think. Just heard about how we were like obviously fully digital through COVID, and then there was like that pendulum that swung straight back as we sort of came back to the classrooms and sort of wanted a little bit less digital times. As we can see, it's pretty balanced. There's a little bit of just a slight preference to print there, but it's sort of still pretty balanced across those three, 50-50 on either side.
Yeah. One of the things we really value at MathSpace is teacher choice. And, if anyone's used MathSpace, you'll see that a lot of what we try and do at MathSpace is use algorithms and adaptive learning, etc., to make teachers' lives easier so that teachers don't have to do everything themselves. But we always look at how do we also give teachers the choice to, do a custom task and pick exactly the questions they want to assign, and pick questions from different textbooks to assign, one from year 7, one from year 8 as they go through. And so, this is kind of also part of our push towards just giving teacher choice.
There's some really positive words there, which is great. We've been doing, like I mentioned before, there's new curriculum for the Australian curriculum, so that affects a large number of states. So New South Wales as well has a new curriculum starting next year. And across some of those states, they weren't as positive about their new curriculum. But with regards to my opinions of this, so something you may not know is that each state in Australia is required to show their alignment to the Australian curriculum. So even though states like Victoria and New South Wales, they publish their own curriculum, they're still required to show that they've got alignment to the Australian curriculum. That was the whole point of it. So basically the Victorian curriculum is, I'm going to throw out a number, probably 90% exactly the same as the Australian curriculum. And then some of the criticisms that I had about the Australian curriculum, Victoria has had the chance to address because they published it 9 months later. So there's certainly a little bit more clarity in some of the actual wording of the outcomes and the elaborations the Australian curriculum has, but the intention and the content is still the same. So it's just a little bit more clear to teachers. So that's definitely a positive. But across the other ways, like across the things like the open-ended stuff, the proficiencies, being able to look at mathematics more holistically in that regard, that's all very similar as well. So changes to the intention of that content. I want to look at general capabilities, and at the end, we're going to touch a little bit on AI and skills and stuff like that. So this is what Vika said their new curriculum is going to achieve, and it's all pretty generic stuff, right? You couldn't publish a new state curriculum and not say these things, because I think people would say, why are we doing it? So there's nothing here that I think jumps out to anything specifically that they've changed. I would say this is like, yep, tick the box. These are the things that we've done. Yeah, there are some things here that they say they did, like resolve the overlap and duplication across curriculum areas. Like kind of by rewording some of the outcomes and elaborations, you've done that, but actually changes in content, no, it's really much the same. And specifically with secondary mathematics, let's have a look at that. So there were 4 main things that they said they did, 2 of them related to content. One is that whole idea about making sure that the 7 to 10 maps into the new VCE study designs that were released last year. So, for next year, sorry. And across 7 to 10, across 7 to 9, I would say that there's not really much change in that regard. A little bit with regards to 10 and then the extension opportunities there, and we'll definitely touch on what that looks like. It's still, I suppose, my general feeling is if we can just make sure that we're not locking students out of pathways too early, if we can make sure that we're giving every student a really strong foundation in mathematical learning and understanding, then I think that's the best thing that we can do as high school teachers. The second dot point is one of the most important, that emphasis on mathematical modelling and investigative processes. So it's that open-ended feeling, which can leave some teachers feeling a little bit stuck because they already feel like they don't have much time to cover the basics. So that's something really important. I'm going to go into that in a little bit in a little minute. So new content, we've got some log scales in Year 10 networks, which is new, definitely in the high school landscape, but that is across the board, across Australia. So this is part of that alignment to the Australian curriculum. So that's also happening in New South Wales and in the Australian curriculum. So we've got some really good content to help you with networks and log scales.
And I know we've got a good investigation on the 3-dimensional coordinate systems too. Yeah,
definitely. Yeah. And Pythag, that moved to level 8 again. That's just to keep alignment with Australian curriculum, which was something that they had to do to stay in line with TIMSS, which is the international testing. So I'm going to start with talking about the proficiencies. So in the previous published curriculum that we had these 4 proficiencies, understanding, fluency, reasoning and problem solving across the board, across Australia. So we're talking Australian curriculum and all the states. We now have this expectation that this is just embedded throughout mathematics. So the way that they've done that is just sort of worded these things through the outcome wordings and the elaboration. So it's sort of just constantly saying these types of words and words that are similes to it. And we're going to have a little bit of a look at some content related to that to show you how we've handled that. And we'll talk a little bit around what each of those 4 proficiencies actually mean. So what you're seeing here is some pages from our printed textbook. So this is 605, divide decimals. And you'll see this is just like a set of textbook questions. So all the different sections in the textbook that we have are divided into those 4 proficiency areas. So it's not just, in some cases, you'll have some understanding questions, and in some sections there'll be reasoning, all 4 proficiencies for all separate sections of the textbook. So we can develop that. It's that real embedding across the curriculum. So what are these things? So an understanding question is, broadly speaking, one of 2 things. What is the prerequisite knowledge that they need to be able to have in order to demonstrate success in the concept that we want to explore right now. So sort of what happened before, what happened in maybe grade 6 or what happened earlier in the chapter, just bring that back to the forefront. And then the second thing that an understanding question will do is, the way I describe it is, it just, you've been teaching something, you've done some explicit teaching for 15, 20 minutes, and you're about to get to do something. You want to know that they listen to you, and you're going to ask a question that sort of summarizes what you've been talking about. Do they really know? Do they know what it is that you've been going on about at the front of the classroom? That's sort of the understanding. Textbook wise, it sort of pertains to that. What's in the box? Like, what was that key thing that we've just covered in that section? Like, what's that key piece of information? It doesn't mean that they can do it. So an understanding is, do they know what it is we're about to do? How does that connect in? What are the key terms, or the way that the formula connects together? Those sorts of things. Fluency, that's more basic. That's that basic the one-step application of the concept that we're exploring in this current section. So that's very common for textbook questions. Everyone sort of does that pretty well. So it's just that one-step application. This is where you'll find mappings to examples, which is also pretty common. So you can go, oh, how did I do that question? Where can I go to find that sort of information? Reasoning is where we sort of build on that a little bit further. So not only can they do it and demonstrate success in the actual calculations or the application, but can they explain why? So reasoning is things like justification, explanations. Error correction is a really, really powerful way to be able to detect reasoning. So can they see someone else's working and identify where that person, where someone might have made a mistake, because that shows a real understanding of the processes involved. Things like pattern identification and extrapolating upon that. So you'll see in this particular example, we provide something that's got a bit of a pattern to it, then they're asked to apply that in different ways. And that obviously in this section relates to place value understanding for division of decimals. We've also got a error correction question there. And then the last one is problem solving. So that sort of takes the fluency and the reasoning, combines them a bit together and goes that one step further. So when we write these, my team would call these complex, unfamiliar questions. So is it something that they haven't necessarily seen before? Have we applied this concept in a different way? So in this one, you'll see we've got something based on perimeter. There's also something here based that sort of incorporates some basic knowledge of rates and proportion. But still we're applying the concept of dividing by decimals to get there. So it's sort of a little bit definitely more literacy, because there's a lot more words sort of involved in the problem solving questions, but definitely there's that sort of unfamiliar aspect and combining concepts together. Yeah,
and those who are familiar with MathSpace would know that often in our old editions of our textbooks that we have a separate subtopic on problem solving. So we might have a subtopic called problem solving with decimals, and we'll kind of combine all of that. But now it's really embedded throughout every single subtopic as you go through, and every exercise has that understanding, fluency, reasoning, and problem solving. A lot of new content, I mean, almost entirely new content. A lot of the fluency was similar than some of the stuff that we had in MathSpace before, but the reasoning, understanding, and problem solving, a lot of new content going in there, more open-ended, explain why not, justify, etc. as you go through.
So the understanding and reasoning sections are sort of definitely where we were open. When we opened, we were talking a little bit about why print. Those sections are a big part of why print, because there's a lot of questions in there that really lend themselves to more of a pen and paper or a communication or a conversation in the classroom around, getting to that level of understanding. And you'll also notice on the page here that we've got these 3 pathways. So that goes some way to also talk around the different ways that we support students through these levels of understanding. So if you sort of broadly think of them as like an easy, medium, and hard pathways, all of those different pathways they all have parts of the 4 proficiencies included within them. So just because you're doing an easier pathway does not mean you cannot reason, and does not mean you cannot problem solve. It might mean that you sort of do some of the easier, you might only do a few parts. You might only do the first part of this particular reasoning question, but it doesn't mean you can't engage with it and start thinking about how to reason and problem solve. So all 3 pathways cover all 4 proficiencies. That was really important to us.
Yeah, I know the team spent a lot of time going like, okay, how do I come up with an easy reasoning problem?
Yeah. What does that look like?
Yeah, how do I come up with a trailblazer reasoning question as you go through? So yeah, a lot of thoughts kind of going into in making sure that we have access to at all those different levels. And it's been really well received, that this feature, the Explore, Adventure and Trailblazer pathways in the print books, where we will be replicating it in our digital product as well, because of how well it's been received.
Yeah. So it also helps with differentiation in the classroom as well. So differentiation on the fly, done easily, is sort of to take these things and be able to sort of, you know, guide students towards a pathway that might be most suitable to them. So that's sort of the 4 proficiencies. Trying to embed that throughout, and we definitely have done that across 7 through 10, every single section, really strengthening out that depth in grade level content area. So we talked about that. I just want to share this quote before we move into the next bit, actually. So this was about 2 months ago now, but David Cavallo is head of ACARA, the Australian Curriculum Assessment Reporting Authority. This was just after there was a lot of media and a lot of sort of educational sort of response to AI and ChatGPT specifically. The second sentence here is what I wanted to draw attention to, that school leavers will need human skills that are not easily replicated by machines, such as creativity, problem solving, adaptability, ethical awareness, emotional self-regulation, teamwork, and critical thinking. Now, of course, because he's the CEO of ACARA, he's used those words specifically because they relate to the general capabilities in the Australian curriculum. Of course, all the states have to show an embedding of the Australian curriculum within their states. So those key ideas and themes always flow through to the states as well. And those words are not words that will be unfamiliar to us in Victoria. So this sort of idea that we still need to focus on the sort of human skills, and the way that they're sort of framed here makes those human skills sort of more that the open-ended, the modelling, the ability to think critically, and all that sort of aspect. So there is definitely in all of the curricula, specifically Australian curriculum, which flows through into the Victoria 2.0, this enhancement of higher order thinking skills, the modelling, computational thinking, the statistical investigation, simulations, and words like that appear very frequently throughout the curriculum. So just as some examples I'll show you, I didn't put all of the outcomes for this particular one on the screen because there was over 12 of them, and they're quite long, as you can see. But outcomes that are focused on that mathematical modelling idea occur across 7 through 10. I know I'm speaking specifically to high schools right now with the 7 to 10, but actually it's across the entire curriculum, K through 10. So we've got modelling standards with a particular focus of the modelling appearing in the strands of number, measurement, and algebra. So that they always sort of start with the use mathematical modelling too. And then they've got, you know, solve practical problems, and then they sort of list a whole heap of things. If you can kind of think about modelling as being, do a mathematical modelling process in any of these 3 strands relevant to any of the content that you've done in that particular year level. That's basically what these outcomes are pertaining to. So they're very large, they're very broad. Simulations is another one that occurs in the probability strand. So there's 1 per grade level. So there's just the 7, 8, 9, 10 there. And like I say, it occurs through primary school as well. With a sort of an emphasis on digital tools for developing the simulations. That's, you know, the ability to do large numbers of trials and things like that. And digital enhancements that are very powerful for this type of learning. We've also got computational thinking. Now, of course, this is something that Victoria has done very well. So from the adoption of the first Australian curriculum 10 years ago, a few years after that, Victoria had their new Victorian curriculum. And the way that they varied from the Australian curriculum at that point in time was to introduce computational thinking via the coding and algorithms type stream, which they did in number and algebra. And so that was where they varied. And that was actually a really strong strength. And I'm very glad to see that they've kept that. The Australian curriculum has introduced computational thinking. Unfortunately, they only picked 1 strand to do that in, which was the space strand. These are the corresponding Victorian outcomes for that particular space strand. So these ones are more specific and matched to the Australian curriculum, but it's really nice to see that Victoria kept hold of their strength in coding and algorithms through their number and algebra coding and algorithms work. And I have an example of that here. So in each of the books for Victoria across 7 through 10, there is an entire chapter dedicated to algorithms and coding. It helps with that development of those key concepts through that computational thinking aspect. So we start off with looking at algorithms. What is an algorithm? How they can just describe real world events. Introduce the idea of being able to follow algorithms and that there are steps. Of course, that becomes important when we introduce the idea of branching. Following that, we've got the idea that we can sort of iterate on things. And then we have a visual way to be able to describe them through flowcharts. And beyond that, we start the idea of pseudocode. And I've been getting some really interesting feedback from the VC teachers, actually, that pseudocode has been really difficult. And of course it is, because pseudocode by definition is like an informal way of representing code. And if you're in VC and you're trying to do, you know, broadly speaking, teach something that's going to be assessed on the whole, you want to make sure that you've taught it in a way that is going to get marked correctly. So we introduced pseudocode very nice and early in grade 7. So there's that ability to develop this notion of being able to represent code in informal language. So that's the coding and algorithm stuff through number and algebra. But also there's these specific outcomes that relate to space and geometry. So those ones are more around being able to design and test algorithms that sort of do like sorting shapes by classifications, be able to design, say, things to test similarity and congruence, those sorts of ideas.
It's really good to see that you had all the proficiencies covered in the algorithms and coding
Yes.
as well.
Yeah, they're all there, yes.
And the pathways as well. So yeah, I think what the kind of really rich coverage of that. It's great.
So where we're at to, so we've done modelling across 3 strands: number, measurement, algebra, simulation through probability, computational thinking through space, but also keeping that richness of what Victoria's done well through number and algebra. And then we've also got statistics covered. So that's the 6 strands, right? So that's basically this higher order thinking, open-ended, modelling type, investigative approach to any of the content that's in any of the year levels, in any of the strands. That's what the curriculum has done. It sounds really massive, right? It doesn't have to be. So let's try and break that down to something sort of much more practical that you could take away and sort of actually implement, like from tomorrow if you had to. The idea of mathematical modelling, you could just Google that and you'll come up with a whole heap of different pages that have nice flowcharts. We just looked at how important flowcharts were in our algorithms and coding chapter. But yes, there's lots of different ideas. This particular one has come from the Australian maths teacher. I always point to that because it's Australian born. It's a journal from the Australian Association of Maths Teachers. So it's a nice strong one. That's the high school one. They break it down into 6 steps. We can also look at statistical inquiry, which is sort of that whole idea about mathematical modelling, but with a statistical lens. Again, you could Google that. You'll come up with a whole range of different articles and sort of different approaches that break it down from anywhere from 10 steps to 5. I tend to break it down to 4. So if you want to think about any of those higher order thinking things that we've got, modelling, computational thinking, simulations, statistical inquiry, you can broadly put it into these 4 general steps. Formulate the problem from the real world context. Construct that model mathematically. Analyze it. That might be iterate on it. It might be test it. And then interpret the answer in context. Like, that's a really broad summary of all of these sort of more complicated ideas in a way that you can sort of go, okay, broadly speaking, let's try and keep on track. So to handle all of those sort of modelling outcomes, you can do that in one of 2 ways. We can do full models, full mathematical modelling explorations. We can do full statistical inquiries, but we'd have to do this full cycle. It's time consuming, which is the biggest thing and the biggest feedback we get from teachers is, I don't have time to do all of this, as well as maintain, you know, that foundational knowledge of skills that I need to develop in mathematics. And it's true, this is a time-intensive process. It needs to be something that you develop over time. You can't just run this in half a lesson one day. It needs to be something that is thought of over a period of time. A lot of schools handle these sorts of ideas through assessment, like through assignments or take-home investigations. Some schools do it through, say, way of a STEM Monday or a investigation Tuesday, and something that they sort of just do one or half a lesson recurrently through the term, where they're working on one of these sort of larger investigative type problems. One important aspect of this is you need to consider the opportunity for students to have a go and leave it and come back. That's sort of that true investigative model. Just think about it. If you were working on something difficult, most of your colleagues would suggest to you, why don't you leave it and come back tomorrow with fresh eyes? And that's exactly the same here for students. We want them to leave it and come back again with fresh eyes and see how that affects their interpretation of the model, or the way that they're going to analyse it. We handle this sort of process in Mathspace in 2 ways. We provide a couple of different options. One is opportunities to practice that full cycle model. So we do that through investigations. And the second is you don't have to do all 4 steps to say that you've done it. If you're going to look at any of those outcomes that are in the curriculum, any one of these steps can be practiced in isolation. And so we provide opportunities to do that through small explorations. So let's have a look. In the investigations in the book, so you'll also see them. I'll show you actually on the flip book. Let's go to sort shapes. No.
So the second one, page 4.
Yeah. Okay. So that's not
Next one.
Yeah, there we go. Okay, so it's the same. Just should highlight that it's the same in print and in digital. So we've got investigations. They are sort of in most chapters. You'll see these little investigations. So we're up here. Angles, lines, and shapes. We've got these investigations. You can just type investigation in the search bar digitally, and you'll find all the investigations. But in the flip book, it's the same. It's still printed there. If there are digital aspects, then you'll need to go to the digital product to access those.
Yeah. They'll be called out as an interactive exploration.
That's right.
It's digital only.
Yeah. So investigations are an opportunity to do that full cycle. So you'll see that they're more in depth. They'll take a couple of lessons, or they'll need dedicated time at home or in other sorts of avenues to be able to get through them. We step them through a process. We have them do little pieces of like steps towards something more higher order thinking towards the end, and then there's always a reflective piece. So the investigations are that full scale, like it can be, this one is in the shape section. So this is part of our computational thinking strand. If we're looking at any of the ones that were to do with number and algebra or measurement, then they'll be in those respective chapters. You don't always have to use, I think these are good. Definitely you could pick them up and use them in the classroom. But sometimes the investigations that you see in these sorts of products is enough to go, oh, that's right, there's that great thing. Or I could just tweak this context to be more specific to my students. So sometimes it's just the idea that matters. And sometimes it's that it's a really great resource that you can pick up and run with straight away. The other avenue, if you don't have or you don't always have time to do the full investigative cycle, but also alongside just developing good rich thinking on the daily basis, are the explorations. Explorations are within our lesson context. So in this particular case, we've got what are we in 1203, classifications of triangles. Just jump there. What's the typo?
I think it was just triangles. I think it was called classification, but then you're going to get a lot of triangles.
Yeah, that's true. That's we'll stick with the digital one. Classifications, that's probably one. So in this particular lesson, we've got these explorations. So pretty much definitely at least every second, about 70% of the lessons will have an exploration. They could be digital, like this one is, where we can sort of explore and play with it, or they might just be a list of questions or something a little bit more static. So the point of an exploration is to pick up one of those 4 aspects of our modelling cycle, but break it right down to something that can be done within 10 or 15 minutes. So you might choose to put this up on your whiteboard and have a class conversation about it. It might be something that they do pairs and shares on their own devices around the room, or you might do them in small groups and rotate around. So you could have a little station, they'll come up in small groups and have this conversation with you. In this particular one, we're looking at being able to classify different sorts of triangles. There's a list of questions at the bottom about, can you make these things? How do we know? What are the sorts of properties that we need to be able to make these triangles? So to support teachers in this, like to be able to identify what are the key things I'm looking for here when I'm having these really valuable conversations with my students. In the digital product, so something that's available digitally, a teacher supports for every single section. So in 1203 Triangles here, we've got a digital teacher guide, which has some fantastic lesson support. So I'll just talk through those real quick. Some targeted and instructional strategies. So these are things that prove as good reminders for, oh, that's a really good way I could approach this particular concept. So some instructional strategies are really well suited to some content. So we've highlighted them here as nice reminders. Some English language learner supports, some students with special needs supports, and then misconceptions on this particular subtopic. So again, if you're an experienced maths teacher, this is a really good reminder to go, oh, that's right, some students do these things. If you've got teachers teaching out of area, and we know that in every faculty there is a lot of those, this is a really good support for them. These are things that they should be looking out for in the classroom, so they can handle these misconceptions before they sort of get embedded in students' learning. But back to the point at hand, which we were talking about explorations, and every exploration also has a specific teacher support. So for that little 10, 15-minute conversation I want to have with my students, what are things that I want to keep an eye out for? What are some of my purposeful questions that I want to be able to ask my students? How do we know? How can I guide them towards this understanding? How can I ascertain whether they have that? And then, of course, an actual misunderstanding that might come up through this conversation that we want to be able to address straight away.
Yeah, it's really cool. A lot of work's gone into this, and really what we wanted to do here is not say, okay, here's an interesting applet, interactive, you can kind of engage with it, and here are some interesting questions to ask, but really, how do we turn this into a kind of a lesson plan, a mini lesson plan for you? So hopefully we can get a lot more usage out of these kind of like engaging things, and really get students to engage them in the way that's intended, where they're developing their conceptual understanding and not just be a kind of nice little slider piece to So yeah, I think this is one of the exciting things, and just how many we have. So it's like on every second subtopic on average, and then the mix of print and digital. So if you are just print only and you don't have, not all your students have digital, then a lot of these explorations are ready for print only. But I think some of the best ones are the digital ones, where even if it's just you on the smart board displaying it, I think it's a really great opportunity to kind of develop that conceptual understanding.
So as a reminder, investigations, full cycle opportunities to practice that, the formulate the model, construct the model, analyze it, test, iterate, and then interpret the answer in context. And then the in explorations are to be able to practice the little tiny things. So this is the same page in the print textbook, and you'll see here that in the print textbook it just says, hey, there's an interactive piece, you can go online to see that. And we also make sure that we call out the sorts of things that we'll explore, so that you can make that choice. Oh yeah, that's definitely worth doing, I'm going to pull that up. Or, oh, I spoke about that yesterday, we're going to move on today.
Yeah. And even with the investigations, the full cycle ones, I saw how you broke them up into those activity tabs. So some of those investigations you might want to spend a whole lesson or even up to 2 lessons on. But you also have the opportunity to kind of pick in and dip in and out and say, okay, we have time for just doing like activity 3. Activity 1 and 2 are kind of to involve. So I know one where we have one on the proof of Pythagoras theorem, and there's one where you got to take the paper out and cut it out and show that the 3 squares, a squared plus b squared gives c squared, by rearranging triangles. Really nice activity if you can do it hands-on. Very powerful to kind of really prove that a squared plus b squared equals c squared. And then activity 2 has like a digital version of that. So, if you've got a lesson to get the arts and crafts out and put things up, amazing. If you don't have time, there's like, you can spend 10 minutes with sliders and do a little mini lesson plan over showing the exact same thing, but through sliders. So Yeah, it's really cool that you can just dip in and out. That's obviously something that's big in the new curriculum, this modeling aspect and higher order thinking. So, but making it easy to making it not kind of overwhelming.
Yeah, try to break it down, make it achievable.
Yeah,
that's right. We know teachers are really busy, so we've talked about all of those things. Fantastic. Okay. Quick chat about 10A course. Has it changed? It kind of looks the same. For Victoria, it does, because they sort of kept it as part of the course, just where it's sort of visible on the curriculum website. They gave all of the 10A sort of outcomes their own codes, so it sort of feels like a course. But as it turns out from our conversations with Vika, the intention is actually different. The intention matches how the rest of Australia and the other states are taking this sort of 10A, or optional sort of year 10 content. Essentially, it means that we want to provide all year 10 students with opportunities to be extended as far as possible along that curriculum, our continuum. So, I mean, of course, you will have some students in your school, and you'll have a group of students in your school who are all going to be capable of doing 10A. You might group them together and you can run them through that content in a different way. But also, you might just have a normal sort of a fairly standard year 10 course, and you're doing really well, and they're really all of a sudden engaged in trigonometry. So you'll throw them some of the 10A stuff in trigonometry, and you give them the opportunity to see that extension. So it's not that they have to do 10A content to be able to handle methods. Of course, if they have and they're capable in year 10, they will handle methods, or they may handle methods a bit better. But if you do year 10 as a foundational course super strong, you are not ruling students out of pathways in year 11. So it's about taking that opportunity to know your kids and know where you can extend them, know where some students, an individual student might have a particular interest in geometry and proofs, let them go there. You might have someone who is really passionate about further trigonometry or really gets the functional stuff, they can go there. So it's harder, right? It's harder to implement. It's harder to think about how you might manage that in a classroom, because you're going to have students doing different things, possibly. So the key word that they use in the documentation there is teachers will need flexibility. So yes, we're all very flexible, and it doesn't make it easier. But I do believe that the intention behind that is much better for kids. Like, to be able to have every kid have the opportunity to go that little step further if they're ready is really powerful. What that'll look like in the year 10 book. I haven't made the Victorian one yet ready to show on the screen, but it'll look very similar to this because, of course, it's aligned to the Australian curriculum as well. So there'll be one book for all the 10 and the 10A content together, because that gives every student that opportunity to be extended through those chapters. Every single chapter will have the optional content as stipulated by the year 10A curriculum in Victoria. And in other cases, there will be also other chapters that have extra, because it's about providing opportunities for extension. So you'll have them marked at the end of the year 10. Of course, at the top, they'll have the actual year 10A Victorian outcome code, because Victoria has numbered their codes. But you'll see every single chapter will have the opportunity for extension. So through indices and surds, we've got opportunities for extension. In exponentials, we've got opportunities for extensions in here through way of transformations. Some entire topics will be opportunities for extension through further trigonometry, through counting methods. We've got the standard networks content, which is part of the core course. It's not part of 10A, but that's all new. So you'll definitely enjoy seeing that new content that's there. Show you a little bit about what that looks like. So all the network stuff is there. This is a really fascinating topic area. So if you haven't taught that yet, I think you'll enjoy that. It's quite nice. But yes, every sort of single topic has opportunities for extension. So that meets the intention of the 10A course by VCAR as well as around Australia. So just wanted to show you a bit about how that'll look and how easy it will be to find, and hopefully, because it's all in the one place, how easy it is for you to take a student or groups of students in that direction if they're ready.
Yeah, I agree. I really love the intention behind this, where it's not an all or nothing approach. You don't have to, from as early as year 10, say you're on an advanced pathway and and you have to do the entire advanced pathway, you can kind of dip in and give that teacher the flexibility to say, okay, what are the most important things that I need to cover if you're trying to prepare your students for methods? What do you want to give them kind of early access to? Because you might not have, it's not all or nothing, where it's like, if I don't finish all of it, then I can't do any of it. So hopefully you'll be able to extend, a lot of students who maybe not necessarily on a methods pathway, but still can get some exposure to some of the interesting optional stuff that they might be interested in.
Yeah.
I particularly like some of the counting and networks, because there's no prerequisites to that. There really is, like, anybody can start to learn networks without, even if you're not great at algebra or you're not great at geometry, it's okay. Networks has kind of very little prerequisites, and same with counting techniques. There's a little bit of probability in there, but it's if you know how to count,
you can also do it by brute force. You can still just write it out.
Yeah.
So you can still engage.
Yeah. I think it's a really great opportunity to extend some students into those areas. And
again, all of those sections will have the easy, medium, and hard pathways. So you might want to start them off in that area, but just give them that sort of explorer, that sort of early pathway options, just like get a bit of a taste for it. Yeah. All right.
So that's kind of the end of the formal kind of the presentation on what's changed, what's in it, what MathSpace is doing. I've got a little bit of time to go through some of like what makes what MathSpace is doing to get that kind of best of both print and digital, and some of the new things that we're working on. In the meantime, if anyone has any questions, please put them in. I've answered a few of them as they've come through on the chat. So do take a look at that. We had a question is about 10A. Is 10A 10 advanced? And kind of discussed how it's more like optional than advanced. It is advanced content, but it's more you can dip in. It's not an entire course. There was a question about the chapter order designed to be the intended teaching order.
No, the answer is no. Let me show you. Structurally on the left-hand side, here is the. So you might be using another book. Let's go front page. Back here. The chapters we organize in the three main sections. So broadly speaking, you've got your number algebra, measurement geometry through the middle, statistics probability at the end. It makes it very predictable. I try and make the content findable and very predictable for teachers. So to that extent, each section here, like 101, 102, 103, a lesson's worth of work, predictable amount of work. What is achievable for a teacher to be able to teach in a standard sort of 40-ish minute, 45-minute lesson. That includes, like maybe a 10-15-minute conversation around that exploration that we've got there, and then some time for consolidation. So when you're planning your units, you can know that these are predictable amounts of work, except for the investigations. Of course, they're not numbered, and we've talked about how they should have, they're more open-ended and take a little bit longer. But certainly our chapters are not like a teach the book from beginning to end. It's more around, you need to think about your own scope and sequence. How do you want to break it up? Whether you want to do a bit of, like, say, some of the primary schools do, a bit of the number and algebra, measurement geometry, and statistic probability throughout the entire year. Or whether you just sort of want to do, let's just do chapters 1, 2, and 5 in term 1. But certainly within the chapter, there's a definite sequence of development of knowledge there, and sort of rely that you've sort of done 102 and 3 before you do 107, for example. So, but yeah, I try and do predictable amounts of work and predictable structures of the books. Yeah, obviously within the strands, the order is, as you'd expect. So, like, if you have chapter 1, 2, 3, it's kind of in chapter 3 we'll have some questions that might have prerequisite knowledge of chapter 1 and 2. Because that's all number. That's right. Within number, within algebra, within measurement. Cool. We have had a question about, is it possible to book list just the hard copy text without the online section for a year level? Yes. So I'm may as well. We're very transparent about our pricing, so I'm happy to share it here. For the digital versions, $30, you get access to all that new content. For the print book only, $60, and then for the combined digital and print, $75 for that bundle. So
you can pick and choose whatever is suitable for your school. Okay, I'll quickly talk about the kind of print and digital. I might take your screen.
Yeah.
Okay, I think I've stolen it from you. Right. Okay. Cool. So with the text and the digital, one of the great things about this is it is totally aligned. So the Vicky 7 book is 13.06 is 13.06. The student lesson in maths-based digital is the same as the student lesson in the print, where we have an exploration. We've already seen they get called out that it's an interactive exploration, so it might be a good idea to try to go online if that sounds like an interesting exploration. Here's a nice one on parallelograms. As you go through, change the slant height and change the slide and show that it turns into a rectangle with some questions to get you thinking of why it's length times width. As you go through, and your idea summary. So one extra thing you get in the digital, so why I always recommend, I think if you do get the print, you may as well get the digital because you get so much more in the digital. One of those things is video walkthroughs. So every single work example has a video walkthrough. We've really bolstered the amount of videos that we have. On average, every second one of our digital questions also has a video. So we've increased the amount of videos that we have by maybe 5-fold inside the product, which is really helpful for students. And we actually collect data on what is the most helpful type of help. And those who watch a video, who take the time to watch a 2-minute video explaining a question, their correctness after just really increases. So we really added a lot more of those. Of course, Erin had talked about the teacher guide, which is digital only. So all these kinds of lesson supports as you go through, these stems for students, for English language learner supports, for example, the mini lesson plans that you have, that's only in the digital side. Then on the practice side, so those who are familiar with MathSpace, you would know about all our digital practice, that step-by-step support and hints and videos that we give students as they go through. And then the kind of scaffolding, the adaptive task. So when a student does this question, you can see initially we start with scaffolding, what's the length, what's the width, and then therefore find the area. And as students get those questions right, all our numbers are randomized, so we can ask them lots of times until they get those questions right. And as they do, we'll start to progress to questions where there's no scaffolding, and then questions where we add some extra things in to make it harder as you go through. So and of course, those who are not familiar with MathSpace, you're able to also customize this. We talked about teacher choice. So you're able to go, okay, I like that question. I want to create a formative assessment for my students as I go through. Pick any question you like, and you get that formative assessment as you go through. Students get that help with hints and videos as they work through that. So that's the adaptive side. That's something that MathSpace has always been really strong at, real digital leader in that space. And then the worksheets is the offline side. So you don't have to, if you're fully digital ready, you really don't need to buy the textbook. And we want to provide that option to schools who don't necessarily want to. And we wanted to also make that really a kind of affordable. So what we do is that's still just $30 to get access to the entire textbook in digital form. So that's an option for you. And you can see here the understanding, fluency, reasoning, and problem solving that we have throughout there. You can assign this, which will give you students a link to take them straight there. You can download as a PDF, view the answers, etc. as you go through. So that kind of gives you, I think, an idea of, okay, what's the print, what's the digital, how do you get the best of both worlds? Of course, for those who haven't seen MathSpace before, a little show of when you do assign these digital practice questions. The big thing that makes MathSpace so different to any other digital product is the ability for students to go through and kind of work through this step by step. So if I go through here and k minus 3 equals 5, I can actually show my work as I go through. And if I did this and if I ask for a hint at this point, it'll give me a hint to reverse the 3. Another hint, I can ask for another hint, add 3 to both sides of the equation. This is a newish thing that we're working on just to show it in a more engaging form for students. And I'll talk a little bit more about what we're prepping for in this kind of more conversational approach. Another thing I just want to quickly show is what if a student did this another way? What if a student instead went through and expanded the brackets? And that's fine too. And if a student got stuck on that step and they ask for a hint, then their hint would tell them to solve it from here. So how do you find 2k on its own? We need to add 6 to both sides of the equation, and a student can continue from there. So that's one of the things that makes MathSpace really special. So that's still in there. The questions, the digital and the worksheet questions, there's some overlap, but they're not exactly the same. We talked a lot about how we've got a lot more understanding, reasoning, problem-solving, open-ended questions in the worksheets. A lot of the fluency questions will be similar. Some of the problem-solving questions will also be quite similar, where they can work through in that way. Okay, we've got 1 more minute, so I'll check if we have some questions. We've got a couple of questions coming in, but I just want to give you a taste of one of the things that we've been working on. One here. Yes. Okay. So we showed just a second ago how we've kind of turned our hints. Obviously, we have the videos, like I mentioned before. We have increased the amount of videos that we have, and the videos will show similar questions with different numbers. And you can ask for a hint and all of that. Something new we've been working on is, I'm sure you've all heard of ChatGPT. So how can we turn hints from being a one-way conversation of just like, okay, I asked for a hint, MathSpace tells me, and now what? To a two-way conversation where students can ask questions. So we've been kind of training ChatGPT on maths. We've been basically feeding it our step-by-step solutions and hints to then be like a tutor for students who can ask questions as they go. So this is a really exciting feature. So here I'm looking to add these two mixed fractions. Let's say I'm not sure and I just want to save space to ask questions of my tutor. Ask, do I just add them? And like, yeah, you need to add the two mixed numbers. First, let's break it up into a whole number and a fraction as you go through. Okay, so you can add the whole numbers and fractions separately. And so what's really great about this is obviously you can proactively ask questions. If you don't understand a hint, you can ask for more detail. It's also a safe space where students can kind of test their answers out. So if a student wants to just say 7 over here, they'd be marked wrong. And this is kind of one of the frustrations sometimes the students have with MathSpace. Like, I want to show my working, but you keep marking me wrong. But over here, if they kind of wanted to just test the waters out and they said, okay, so 7, and you can see Milo, a little puppy AI tutor, says, yep, that's correct for the whole numbers. Now let's get to working on the fractions. Can you find the least common multiple of 8 and 9? And again, we can kind of say, is it 17? And they're just adding 8 and 9, like not quite. Okay, and you can see it gives you kind of more detail of how to go about doing that as you go through. So really exciting kind of feature. Some of the things that you get is students says it's the most common question. What is the answer? And of course, I can't give you the final answer, but I can help you work through the problems. And so one of the philosophies we have as we're building this is, if we can make it easier for students to learn than to cheat, then we believe they'll choose to learn every time. And so we have to have that kind of opinion of students and then just put those guardrails in place to say, well, it's easier for you to learn. You can always cheat and go and ask ChatGPT and it might just give you the answer. But we're going to make it easy for you to learn. The question's already in here. It's already preloaded. The guardrails are already in place as you go through. And the other thing we want to do is really make it safe. So teachers can always see the chat. They'll know that if their students have been using it, teachers have the option to turn off the chat. When they assign a task and want it to be more of an assessment, they can turn it off. And if students get a bit funny and say some bad stuff, then you can say your message has been flagged as inappropriate. At the moment, we are checking these manually and kind of alerting teachers if something really needs a follow-up as it goes through. We don't want to kind of over-alert teachers as well. So that's a really exciting thing that we've been working on MathSpace. And I hope what you kind of see is what we're doing at MathSpace is really responding to teachers' needs, responding to students' needs, and not building technology for the sake of technology. And actually, even when we feel like a low technology solution is the better option for learning, let's work on that. And where a technology solution is the better option for learning, how can we make that the best way to learn? So, all right, with that, I'll go to some questions. Yep, we talked about the book listing, do the questions line up, practice section line up directly with the questions in the book. So I just talked about that. At the moment, it's not possible to assign an Explorer or Adventurer set to a group of students online because those questions are to be done offline. But as I showed, you can pick and choose your questions when you're going through to assign. So yeah, and it's not an exact match with the two different versions as you go through. So the adaptive task, as we talked about, is not an exact match. You can pick those questions that way. Have you considered flowcharts for solving equations?
Yeah, we do have flowcharts for equations. I have to find out which book it is. But yeah, we do have that.
Awesome.
Yeah.
Great. I think we've got all the questions answered. Okay. Thanks so much, everybody. We'll stick around for the next couple of minutes if anyone does have any final questions. Otherwise, thank you so much. And we'll see you around, and hope you enjoy the maths-based textbooks. If you have any questions, do shoot us an email, etc. I hope a lot of you will be using the textbooks, and whether digital or print, for next year.